Alright, so this video is going to go beyond just simplifying rational expressions. We're actually going to talk about solving rational equations now. So this is actually going to be kind of similar to the method that we used to get rid of denominators when we did complex fractions. So for our example, the instructions are just going to ask you to solve. And the problem says 1 over n squared minus n minus 20 minus 2 over n minus 5 equals 1 over n minus 5. So just like we did when we had those complex fraction problems, we had to know what all of our denominators were. And right now we're kind of having an issue with that first denominator because it is not in factored form, and we need to know what the factors are just in case one of the factors matches the n minus 5 for the other problems, or the other expressions, I guess. So we're going to go ahead and figure out what that should be if you factor it. So we're finding two numbers that multiply to negative 20 but add to negative 1, and that would be negative 5 and 4. So that means that our denominator, instead of writing this, I can say that denominator is actually n minus 5 times n plus 4. And that means now that I do know what my common denominator is. So I'm going to go ahead, I'll write that in blue. My common denominator is n minus 5 because all three of the fractions had that, but also n plus 4. Okay, so I'm going to rewrite this just so that I have a cleaned up version to work with. So I'm not changing anything, I'm just writing it with that factored form of the denominator. And what I'm going to do, I guess this one didn't really need those parentheses. Okay. And what I'm going to do is I'm going to put parentheses around this entire equation, because what I'm about to do is I'm going to take something and I'm going to multiply it by the whole equation, the left side and the right side. And that's how I can kind of get away with doing it, is because I'm doing it to both sides of the equation. So what I'm going to do is I'm going to take my common denominator, and that's what I'm going to multiply by everything in the equation. And this should be reminding you of what we did with the complex fractions. Okay, so I'm going to take this right here, and first I'm going to multiply it by the first piece. So what you'll notice there is that if I have the n minus 5 and the n plus 4, and I am multiplying them by the first fraction, then the n minus 5 and the n minus 5 are going to cancel, and the n plus 4 and the n plus 4 are going to cancel, and from that first term, all that I'm going to have left over is the 1 on the top. So I'm going to go ahead and write that. I'm not going to leave all that there. So I'm going to say from the first term, I just have a 1 left over. Okay? And then I'm going to go ahead and take that, and I'm going to distribute it to the second part now. So we do have that minus in the equation. And the n minus 5 is going to cancel with the n minus 5, and all that I'm going to have left over is that 2, as well as this n plus 4 over here. So I'm going to go ahead and write that. Sorry, it's so much easier to write this when it's zoomed in. So we've got 1 minus 2 times n plus 4, because that didn't cancel. And then I'm going to go ahead and do that third piece. So we have that common denominator is being multiplied by the right side of the equation. So it's being multiplied by the third piece that we have. And again, the n minus 5s cancel out, but the 1 does not, and the n plus 4 does not. So that equals n plus 4. And now all I have to do is solve this pretty simple equation. So I'm going to go ahead and just kind of start doing my work. I know that the first thing I want to do is get rid of that parenthesis So I'll go ahead and distribute a -2. So I have 1 minus 2n minus 8 equals n plus 4. And I can combine like terms. So I have -2n minus 7 equals n plus 4. And then I can go ahead and get my n's all over to the same side. I'm going to move them all to the right. And so that gives me -7 equals 3n plus 4. And I can subtract 4 over to the other side. That gives me -11 equals 3n. And then I'll go ahead and divide by 3 on each side. And I get -11/3 is the solution. So before I can make any conclusion that this is like the perfect answer here, I do need to go back to the problem and check out my excluded values and just make sure that I'm not running into an answer that I should have excluded. So if you look at the first, I'm going to zoom out. If you look at the first denominator, n minus 5 and n plus 4, the values for n that we cannot have are +5 and -4. So I'm going to specify over here n cannot equal +5, n cannot equal -4. And that's because they would have made that fraction undefined. So if you look at your other fractions, we have n minus 5 and n minus 5. And so that just confirms those excluded values we already had. So if I look down at my answer, -11/3 is good, because it's not that excluded value of 5 or -4. So that's a good final answer to have.